In this video, we'll start with the next experiment, that is the use of IC 74193 as a universal shift register. The aim of this experiment is to verify the truth table of this IC as a universal shift register and also to implement a ring counter. A shift register is commonly used in digital electronics either to store data or to move it, and a shift register can be used to shift bits from either left to right or from right to left. The apparatus that we require is a base board, the IC 74194, and a couple of jumper wires. The procedure again is very similar to other experiments. You will have to mount the desired IC in any one of the 10-pin sockets on the board, and using the provided circuit diagrams you can make the necessary connections. So as seen from the diagram, you have pin 16 connected to VCC and pin 8 to the ground. You will have to connect clear, that is clear bar, to plus 5 volts. Then for pins 2 and 7 that denote shift right serial input and shift left serial input, they imply in which direction you want to shift your bits. So in case you want to shift the bits from left to right, then you can set pin 2 to high and pin 7 to low. Similarly, if you want to shift your data to the left hand side, you can connect pin 7 to high and pin 2 to low. These four pins over here, A, B, C, D, denote the inputs, and they can be connected either to plus 5 volts or to 0 volts depending on what your input data is. Then on this side you have pins 12 to 15 denoting the output. So these pins will be connected to the LED box, and once these connections are done, you can see them moving from one direction to the other. You'll have to connect pin 11 to the onboard clock, and you'll have to connect pin 9 and 10, that is S0 and S1, depending on what requirement you have. So if both these pins, that is S0 and S1, are connected to 0, then the status of the register will be on hold. If suppose S0 is 1, then the data is shifted towards the right. If S1 is 1 and S0 is 0, the data is shifted to the left. And if both of them are connected to plus 5 volts, then the status of the shift register is on load. Once all of these connections are made, you can connect the board to the power supply in order to see the shifting action. Let's take an example wherein we connect pin 7 to high and pin 2 to low. Since we connected pin 7 to high, that is shift left, our data will start shifting from the right direction towards left direction. And let's also say that we connect pin 6 to plus 5 volts and all the other pins, that is 3, 4, 5, to the ground. So we'll only have one bit that is high in the input, and we'll be able to observe this on the LED box as only one of the pins will be glowing. We'll also have to connect pins S0 and S1. So looking at the truth table, we can connect pin S0 to ground and pin S1 to logic 1. Since this denotes that the status of the shift register for this case will be towards shift left. And once all these connections are done, you'll observe on the LED box that the one bit that is high will start moving from right to left direction. And in the next part of this video, we'll take up this example and we'll demonstrate how you can make all of these connections on the mobile lab and how the shifting action happens, and we can see the high bit moving from right to left. In this part, we'll demonstrate how you can implement the shift register using the IC 74194.
So all the connections are given in the manual itself. So here we will just look how our output looks when the input given is 0001, which is D is logic 1. So here we can see that the output is going from D to C, then B, and then A, which means that it is shifting towards the left hand side. So we can say that it is working as shift left register.